You know, you can often measure a nation's power by its strategic reach. So today, we're diving deep into the advanced missile technology that is totally reshaping India's place in the world. We're going to deconstruct the three key pillars of its power: its long-range shield, its supersonic sword, and the incredible race for the next frontier, hypersonic speed. So, what exactly is a missile triad of power? It's a phrase you hear thrown around a lot, but it's not just about having a big pile of weapons. It's a core strategic idea that really defines modern deterrence. Let's break down what that powerful phrase actually means in the real world. All right, here's our game plan. First, we'll get a handle on what this triad thing is all about. Then, we'll look at the strategic shield. We're talking the Agni missiles. After that, we'll check out the tactical sword, the BrahMos system. And to finish up, we'll jump into the future with hypersonic weapons and ask the big question, what does all this mean for global stability?
To really get a grip on India's modern arsenal, you have to look back a bit. This missile triad, well, it wasn't built overnight, not even close. It's the result of decades of intense strategic planning and homegrown innovation, all designed to create a deterrent that nobody can ignore.
The whole idea behind the triad is pretty simple, actually. You need the ability to strike back from land, from the air, and from the sea. It's all about redundancy and survival. Think about it. If an adversary somehow manages to take out one leg of your triad, the other two can still deliver a devastating response. It's kind of like the ultimate insurance policy, designed to make any potential attacker think twice, or three times. In this timeline really shows it's been a long, deliberate journey. It all kicked off back in the 1980s with a foundational development program. Fast forward to 2012, and you have the test of the long-range Agni V, which was a huge strategic leap. By 2023, the program got so matured that India started exporting the BrahMos missile. And looking ahead, the goals are, well, even more ambitious, aiming for next-gen systems and even directed energy weapons by 2050. Okay, let's talk about that first pillar of the triad, the Agni missile family. This right here is the long-range strategic shield. It's the absolute backbone of India's nuclear deterrent. Over 5,000 kilometers. Just let that number sink in for a second. That's the operational range of the Agni 5 missile. From India, a range like that puts all of China, most of Asia, and even parts of Europe within reach. A capability like this doesn't just change the game, it fundamentally rewrites the entire strategic map.
Now, the Agni system isn't just one missile. It's a whole family, with ranges from medium to intercontinental. And its main job is nuclear deterrence. A couple of key features make it so effective. First, it uses solid fuel, which means you can launch it way, way faster. Second, it's mobile. We're talking launchers on trucks or trains, which makes it an absolute nightmare for any adversary to find and destroy before it can be fired.
And just when you think it can't get more advanced, it does. MIRV technology. This is a total game changer. Imagine launching one missile, but instead of one warhead, it unleashes several, and each one streaks towards a completely different, independent target. The whole point is to overwhelm any defense system, making it nearly impossible to intercept. Okay, now let's switch gears to the tactical sword of the triad, the BrahMos cruise missile. If Agni is that big, strategic shield meant to prevent a major war, BrahMos is the weapon you might use to actually win one. It's built for precise, lightning-fast strikes, and its greatest advantage is just pure, blistering speed. This really shows you why BrahMos is so dangerous. A typical subsonic cruise missile is, well, it's slow. It gives the enemy time to see it coming and react. But BrahMos? It's traveling at nearly 3 times the speed of sound. That incredible speed shrinks an enemy's decision time from minutes down to mere seconds. It makes a successful defense incredibly, incredibly difficult. And its versatility is just a massive strategic asset. You can fire the exact same missile from a warship, a submarine, a fighter jet, or a launcher on the ground. This whole one missile, many platforms approach gives military planners incredible flexibility to strike from pretty much any direction at any time. And now we've got to look to the future. The next huge leap in military tech is already happening. It's the global race to develop hypersonic weapons. And this isn't just a small upgrade. We're talking about a technology that could be as revolutionary as stealth fighters or even the atomic bomb. Mach 5. That's 5 times the speed of sound. This is basically the barrier to entry for hypersonic flight. At these kinds of speeds, the air itself can turn into a superheated plasma around the vehicle. For any current defense system, trying to intercept something moving that fast and that hot is a monumental, if not completely impossible challenge. So, what makes them so tough to stop? Well, unlike a ballistic missile, which follows a predictable arc, kind of like a thrown ball, a hypersonic glide vehicle is totally different. It gets boosted high into the atmosphere and then it glides, but it can change direction and altitude while it's in flight. This makes its path utterly unpredictable. And as they say, you can't shoot down what you can't track. But mastering this tech is unbelievably difficult. It requires breakthroughs in pretty much every field. You need totally new materials that won't just melt from the insane heat. You need advanced scramjet engines to keep up that speed. You need guidance systems that work perfectly at these crazy velocities and sensors that can somehow see through the plasma that's literally wrapping the vehicle. It's a huge list of challenges. So, what are the global implications of all this? This relentless chase for more speed and more stealth is really starting to rewrite the rules of strategic stability. The reasons behind this big push are pretty clear: strategic competition with regional powers and the desire for a decisive technological edge. On the economic side, there's also the ambition to become a major defense exporter. But the challenges are just as big. The technology is incredibly expensive, mass production is a whole other headache, and every new development risks kicking off a more dangerous and unstable arms race. This quote really captures the ambition behind the entire program, doesn't it? It signals a big shift in mindset, from being a nation that mostly acquires military technology to one that is now on the cutting edge, pushing the boundaries and creating it. So the crucial thing to take away here is that these systems are all designed to work together. Agni provides the ultimate strategic backstop. BrahMos gives you a flexible, precise strike option for a conventional fight, and the whole pursuit of hypersonics is about securing that decisive technological edge for whatever comes next. Together, they create a layered, comprehensive toolkit for national security.
And that leaves us with one last, really critical question. Sure, this technology might enhance one nation's security, but what does it do for global stability? When weapons can strike anywhere on the planet in minutes with almost no warning, how does that change the very nature of conflict and crisis? That is the challenge of this new, incredibly fast era.